Hello, myself Tamichelvi, Assistant Professor, Department of ECE, K.S.Rangasamy College of Technology. Now, in this video, we'll see about the Zener diode characteristics, how the Zener diode works in forward and in reverse bias condition. First, what is a Zener diode? Zener diode is a type of diode that permits current not only in the forward direction like a normal diode, but also in the reverse direction when the input voltage exceeds the breakdown voltage named as Zener knee voltage or Zener voltage. Here in this slide, three different symbols are drawn here. First one on the left side, it shows that it is a 4.7 volt Zener, and in the middle, three different symbols are drawn here. For first one, it represents appearance symbol, that is how Zener diode looks like practically. And the below one, it represents the schematic diagram symbol of a Zener diode, and below to that it represents the arrowhead, that is the direction in which the Zener current starts to flow. The Zener diode has two terminals, one is anode and the another one is cathode. Usually this ring coated end, it is taken as a cathode, and the arrowhead, it represents that there is a possibility of the reverse current flow, that is current flow from cathode to anode in this Zener diode, but this occurs only if the voltage input voltage exceeds the Zener breakdown voltage. That is explained here. The arrowhead of a Zener diode symbol points in the direction of forward current when the diode is forward biased, and when Zener diode is normally operated in the reverse bias condition, in that case the current direction will be from cathode to anode. The most basic common Zener diode circuit, it consists of one Zener diode and a resistor. Zener diode provides a reference voltage, but a series resistor must be in place to limit the current into the diode. Otherwise, a large amount of current would flow through it and the diode will get destroyed. So, a resistance R could be selected such that it limits the current flowing through that diode. And the value of the resistor calculated to give the required value of current for the based on the supply input voltage what we are given. Here the input voltage is V1. So Zener voltage here we have taken it as V2. So V1 minus V2 divided by R, it decides what is the value of current that flows through that resistor R. So based on that current value, we have to choose the appropriate R value. In forward bias, that is connecting the positive terminal of the battery to diode anode terminal and negative to cathode. In that case, if positive is connected to anode and a negative to the cathode terminal, means then we can say that the diode is in forward bias condition. In forward bias, the electrons and holes are swept across the junction and large current flow through it as like that of the normal diode. In reverse bias condition, here the negative bad terminal of the battery is connected to anode and positive is being connected to cathode. So in this case, current practically it remains zero, and at a certain voltage called as Zener voltage, the current increases sharply. Each Zener diode has breakdown rating which specifies the maximum voltage that can be dropped across the diode. So based on that breakdown rating, we could identify that what is that breakdown voltage of a Zener diode. So this is a Zener diode characteristics. In the forward characteristics, it is same as that of an ordinary forward bias junction diode. Whereas the reverse characteristics, if you say that once the input reverse voltage it exceeds the breakdown voltage, there will be a large current flow through the Zener diode. That is, the junction is said to break down at that voltage. So this is the characteristics of the Zener diode under reverse bias condition. So how this reverse characteristics carries over inside this Zener diode? If you see that Zener diode, it is practically a PN junction diode, right? So connecting a negative terminal to P type and a positive terminal to N type, it makes that majority charge carriers available in the P and N type region to move away from the junction. That is, these carriers are being attracted by the battery. So the majority carriers are now pulled out of the junction, so depletion region gets widened. So if we go on increasing the reverse voltage, depletion region with also go on increasing it, it leads to an breakdown in that junction. So at one point that is said to be as a breakdown voltage of that Zener diode. On that condition, Zener current starts to increase tremendously. So the most common application of Zener diode is Zener can be used as a regulator, it can be used as a comparator, limiter, and in power supplies to limit the applied input voltage. So these are all the few questions that you could answer it based on this understanding of this presentation. Okay, try it. Thank you.